see how long that lasts. So Randy, is this a question or do you need?
No.
Is it okay? Yeah, that's good. That one's good.
But that one, just right here, Jeff. Jeff, can you like that one, the last one? It's like homework.
The last one?
Yeah.
This one here? That one? Or this one?
This one.
This
That
one?
one, yeah.
Oh, I see, okay. It's from the homework? One problem with that is there's too many equal signs. So I need to see what the real thing says. So do you know what part of the homework it's from?
I told you there's no two equal signs. We just kind of winged it. We just need the X go away, so there's only one equal sign.
But Carl, that came out of the homework?
And he had it in paper. I got it before you were signing, so there's no telling.
Yeah, I don't know where that came from, Randy.
I got this suspicion that 8x is a minus 8x, or a negative 8x, or something.
Yeah, what I think it is. All right, guys. People. I think it's probably this. So I think it's probably from one of the earlier sections. So how would you solve this equation?
7.
So this is a classic place to get to in solving an equation. Maybe there's some work that was done before this. Maybe somebody had distribution. They got the like terms together. And very often we get to a point where x is in numbers, and this is where you just choose a way to go. So all your x's have to be on one side. All your numbers have to be on the other side. So whichever way you choose to move things is going to set up which way to move the other things. Right? So which way do you want to move what?
The X is to the left.
So move the x's that way? Or you said the x's that way? So how do I kill this?
7x.
Minus.
7s.
Okay, so you can kill this if you want to. So you're moving the x's that way. That's cool. Right? Because they're going to disappear here. Is that? So that's what I mean when I say move the x's. Of course, you can't just pick them up and put them over there because they can't just magically go to the other side of the equal sign. The way to actually move it is to disappear from one side. And that's why you're always doing the opposite operation, right? And effectively, then they show up on the other side. So you get negative 1 equals x minus 4. And now you're one step away because the only thing that's not in the right place still is the number. The 4 is in the wrong place. All your x's are cool, but your numbers should be away from the x's, right? Keep those guys apart because they just don't get along, whatever. So add 4 that cancel there. X equals 3. That's what I think it is. And a real quick word. I'm going to continue to correct you guys if I see people doing this. This is just, I see people doing this kind of thing all the time, and they say, okay, negative 1 equals x minus 4. So the big problem here is equal sign is supposed to show two sides. So if you have several equals in a row, what the hell? My equation has to be its own thing, right? So you could say like this. I've lost the size. I can say like this becomes that. But if some of you guys see I've drawn, if you have equals, I've drawn a line through it saying don't put that there, it's not good format. If you go into Math 90 and you're doing it, they're going to say, who's your ADA teacher? Waller? Look at the top.
Does it matter? Depending on which side you move the x's to, the x could be x equals 3 or 3 equals x, right?
Exactly.
So somehow we came up with the right answer though on that. On the bottom here.
Yeah. That's good. For one thing,
Bam!
no. Carl, before you go bang, 5 divided by 15?
Well,
we get 3.
We had to reverse that to make it work.
So you had to do the opposite of what it said you should do.
Right.
All right.
But it worked.
No, it didn't. Yeah.
But still right?
So many things wrong there. All right.
That's how you make us write our work out.
Yeah.
But it's still right?
No.
2, 3?
So guys, the way to lose the most points on a test or a quiz is to show me that you don't understand the process of something. If you come up with the wrong answer, that's not good, but it's better than not having a clue how to do the problem. So if you come up with the right answer for the wrong reason, you better believe you're going to lose more than half the points. Because my point system is based on, if you show me you understand, I can forgive some simple mistakes. You with me? So I'm not, if you say this is 5, okay, that's bad. Negative 1 plus 4 is not 5, but it might have just been the heat of the moment, long-ass equation. At the end, your brain just poured out. That's fine. I'm not going to take a ton of points off. But if you start off by adding 7x, okay, that's bad. That's a concept problem. That wouldn't cancel that guy out. You guys kind of with me? The concept is what I grade heavier on. So getting the right answer, I want you to really understand. If you get the right answer the wrong way, that's bad. That really is. Because then you start to believe the way you did it was right. And then every other problem is not going to work. You just got lucky on that one problem. And you got lucky because you did several things wrong and they all ended up being the right thing. And I get people that get upset at me because they say, well, 3's the answer, Jeff. And I'm like, I don't care. The main deal with this class is get the process down. So if you just get lucky, I'm not going to give you points. I'm sorry. I'm not a casino, right? Pull the lever. 3. Yay, you won. No, screw that, right? So that's why I desperately have to see your work. Because if you don't show me your work, you might have done something wrong but got the right answer. And that doesn't help you. That doesn't help you. You don't learn that that's not the right way to do it. So anything else from homework?
4.3.
4.2.
4.3?
Number 18. On 241.
Were you asking something about this or no?
No.
Okay, just a sec. 4.3 number, which one?
18.
18, now let's read. Okay, so this is actually like one step beyond what we did together in class. We got into 4.3. We haven't gotten all the way through 4.3 yet. So this would be a good little review. If I string of fractions all multiplying, I can cancel stuff if they are where? Related to each other.
Bottom on top.
Yeah, one's got to be at the top, one's got to be in the bottom, right? So the way to start looking at this, if you need to, you can break each of these numbers down, but I'm hoping we can get away from that, because sometimes these numbers will be long in breaking it down. What you can start to do is say, can you immediately see anything? There's the one that's really not too bad at all. Anything that's on the top and the bottom that's something you can divide out of both. Can you guys see that? Yes? Yeah, the 10 and the 30, right? So you can divide both of those by
10.
10. 10 divided by 10 is 1.
10 is 3.
30 divided by 10 is 3. So what I really just did, just forget about those for a second. I really just said, okay, 10 is 10. That's amazing. But 30 is 10 times 3. So if I cancel those 10s, I'm left with a 1 and a 3. Are you guys with me? So that's the shortcut to writing all the factors out and canceling the common factors. You just have to be able to see what's common to both numbers to start with. So a 10 is definitely common to both of those. Is there anything else that has something in common?
32.
Yeah. 16 and 32. What's common to both of those?
16.
Good. 16 divided by 16 is
1.
1. 32 divided by 16?
2.
2. There's one more thing I could do.
3 with the 27.
3 is on the bottom. 27 is on the top. 3 goes into 3. 3 goes into 27. 9. So anything else? That 13 is screwy. He's prime. He's not going to go into anybody unless it's 13.
So it doesn't matter where in that, if there's 3 or 4 of those, it doesn't matter which section they're in, you just cross
Exactly.
stuff out.
Exactly. Because, now watch. Here's the original problem real quick. Because that's a really good question. I want you to really understand this. If I were to multiply this out, let's say I don't have a calculator right now, but if I were to multiply this out, I'd say, okay, it's 27 times 10 times 16. Is that cool? 27 times 10 times 16 over 32 times 13 times 30. Right? When you multiply fractions, you just multiply straight across. How we know so far? Yes, sir.
You times it, you times every number, like 32 times 13 times 30, and then you...
Definitely, because this is all multiplication, right? So 27 times 10 times 16 is on the top. On the bottom is 32 times 13 times 30.
And then you get the big number.
You could, but let's realize we can be smarter. We can say, let me move the 10 here. Now, why am I allowed to do that? You guys, and I really want you to be with me. It's a lot of writing, and you, please, dear God, don't do it like this. But I want to answer your question. It was a really good one. Why the hell am I allowed to do that when they aren't really on top of each other? Because multiplication, do I have to multiply in the order they gave it to me? I can multiply whatever the hell order I want to. And now look, the 10 and the 30 are right on top of each other, right? So 10 over 30 is 1/3. So instead of doing all this crap, I'm just going to say, oh, the 10's up, the 30's down, I can reduce them.
You do that, if the 10 was where the 30 is way on the bottom right, it didn't matter either, right?
Doesn't matter.
All right.
Yeah.
That'd be 3. That's 10 times 30.
I love it. So just like we got here, this would be 1 and 3.
That 1 and 3, it's like
1/3, because the bigger one's on the bottom, just like the 5 over 15 would be 1/3, not 3. The big one's on the bottom, so that's where the answer should end up.
And then how about the like 1 and 1? 1 and 1/3?
Oh, the other stuff doesn't cancel all the way, does it? So now we start doing like 3 into 27 like we were doing up here. How do you guys feel about this so far? So I know that multiplication and division will cancel. What numbers in this problem are multiplying? 27, 10, and 16. What numbers are dividing? 32, 13, and 30, right? You guys kind of with me? Why are they dividing? Because they are on the bottom. So so these numbers will cancel with parts of these numbers if they have anything in common. That's the idea. Let's do something a little easier to look at. Real quick, what's the answer here? I didn't finish this out.
9.
Good. 9 times 1 times 1 is 9. 2 times 13 times 1, 26. And they definitely don't have anything in common. I knew they wouldn't because I already saw their parts. And the parts don't have anything in common.
Why you get to 26?
2 times 13.
26.
Yep. Times 1 is still 26.
But that'd be 9.
Good. The top will be 9. The top is 9. Multiplying those out. And the bottom is 26. Multiplying those out. Cool. How are we doing so far? So let me give you a little different problem. If I had this problem here, just throw you for a loop here.
It will be 12 of 35.
Maybe. Does anything cancel? No. Yeah, neither one of these has a 4 or a 3 in it, so there's nothing that could possibly cancel, right? So how do you do this? You do 12 over 35. Yeah, good. So you're right. I just didn't want to give anything away. You guys kind of with me there? Yes, sir.
So you just divide, you just times, that's it?
Yes, exactly.
So 4 times 3 is 12, and then 5 times 7, 35?
Exactly.
And then put the big number on the small one?
No, you put the top number on the top. You put the bottom number on the bottom. Don't make it any more than that.
Not the big one, not the big
No. The top number multiply goes on the top. The bottom number multiply goes on the bottom, because that's where they are.
Okay.
So if I divide 12 by 5 and 7, what am I really dividing by? 35. If I cut something into 5 pieces, and then I cut each one of those into 7 pieces, I just made 35 little-ass pieces, right? Mm-hmm. Let me get a slice of pie. Oh, thanks. All right. So why did you do that? So on the heels of that, let me show you this. And we're going to do this problem 2 ways. We're going to do it. So if I had 4/9 times 3 over 11. So let me do it the way that I don't notice something. And I'm sure some of you guys notice something about this problem. But if I just multiply like I did the last problem, what do I get?
3 is 1. 9, 12,
12, thank you.
99.
99. Now, could I reduce 12 over 99? Is there something that goes into both 12 and 99?
Yeah.
Yes.
Yeah.
3.
3.
And then
So if I divide by 3 on the top and bottom,
4.
good, I get 4 over 33. So I can reduce anytime I want to in the problem. When is the smarter time to reduce? Earlier. So don't get these big ass numbers. Now that wasn't very big ass, but the problem we just had, if I multiply all those numbers out, would I get this big ass number? And do you really want to break 5,704 into parts and then see what part? No, I don't. I'd rather deal with the smaller parts first. So what's the other way I could have done this problem?
3 was 9.
Yeah.
3 is 1. 9 is 3.
So the 3 and the 9, 3 goes into 3 once, 3 goes into 9.
3.
What do you got on top? 4 times 1? 4. 3 times 11?
33.
Of course the same answer, right? Because here, what did I do? I divided by 3, top and bottom. What did I do here? I did the same thing, I just did it first. Yes?
4. How you get the 4?
4 times 1?
4.
3 times 11?
But I don't understand that because get that 12 equals 99 because the 3 it's 3 and then that's
So here I just did 4 times 3 as well. And 9 times 11 is 99. Is that cool? And then I noticed I could reduce that because they both had a 3. But here I said, why don't I just reduce that 3 first?
to 27.
No.
9 times
3 goes into 3 once.
4,
3 goes into 9
3.
3 times. 3 over 9 would reduce to 1/3. And then I can just multiply across with the smaller numbers. All right, let's do another one. Let's see. Okay. So the funny thing is, once you start looking diagonally, you forget that you can always look straight up and down too, right? It just has to be one on the top, one on the bottom that are the same, that they can cancel. So what can I cancel there?
6 with 18.
Yes, 6 and the 18, right?
Yeah, goes by 6.
6 goes into 6 once. 6 goes into 18 3 times. And don't forget, what I'm really doing there is I'm saying 6 is 6 times 1. 18 is 6 times 3. 6 just go away, I get 1 over 3. 1 over 3. That's all I'm doing. I just really want you guys to get away as soon as you can. If you're not quite there yet, okay. But get away from having to show yourself all the factors. Just start realizing I can just divide by the biggest number I can think of that goes into both. What else still goes?
3 with 27.
Yeah, 3 goes into 3.
1.
3 goes into 27. 9 times. So 1 times 9.
9.
1 times 11.
11.
Cool. Okay, so it's just a question of not reducing at the end, reducing at the beginning. So when numbers don't get bigger than they have to. Right? Yes, sir.
Yeah, on 4.3, number 12, on 241.
Yeah. Oh, good. All right. So the next step is to, I want to first make sure the numbers are cool. Because the next step is to bring letters in. So what if I had, let's do that.
28.
1.
It's not multiplying, is it?
How that be multiplied?
So what is 8 to the 5th? What does that mean? 5 eighths, right? So I don't want to have to do this every time, but that's 5 eighths. What's on the bottom?
4 is
4 eighths. How many cancel?
4.
1.
Yeah, right, see? Those cancel, those cancel, those cancel, those cancel. So you're left with
1 8.
8.
A to the first, 1A. So why does that make sense? If I have 5 A's multiplying on the top, divided by 4 A's, I'm going to be left with 1A. If I had 5 A's and divide 4 away, I'm left with 1. It's the same idea. Yes, sir.
No times. 5A times 4A is 28.
This is divided.
Divided by 4A.
And these don't say 5A and 4A. These say A to the 5th and A to the 4th. Right?
20A.
No. It's not 5A times 4A. That's very different. This is a to the fifth divided by a to the fourth. Very different stuff, right? So, for example, if I had, let's see, 16 divided by 2. What is that? 8. So let me overanalyze this. We know it's 8. So 16 divided by 2. Isn't 16 2 times 2 times 2 times 2? You with me? Right? Isn't that 2 to the 4th divided by 2 to the 1st? What's 4 minus 1?
1,
3. So if I have 4 2's divided by 1 2, how many 2's will be left?
2.
3 of them, right? Just like right here, I can see it. And what's 2 times 2 times 2? 8. 2 times 2 times 2 is 8. So when I have letters are nicer than you realize. They have to already be factored. So when I have a problem like this, what you got, Jeff?
Like numbers and letters.
If I had this problem here, oh, that would be even worse than I want it to be. There we go. That problem sucks. Do you guys feel the same way? Okay. So how do you start to attack that problem?
Do
The right answer is not to take your calculator and divide, because it would probably be on this part of the test that you're not allowed to use calculators on. Shit.
times by
Make it
27.
to small pieces.
I know what you're talking about, but you can't just multiply this by 27 out of nowhere. This is a number. I can't change that number. I can just see what that number is. I have to do what this says.
Divisible by 3.
Good. They're both divisible by 3. Right, so this would be 3 times what over 3 times what? Well, the bottom is 3 times 9. And the top is 81. Yeah, 81. Right? You cool this? Oh, you good? So 3's go away, right? And of course, 81 divided by 9. 81 is 9 times 9 over 9. One of the 9's go out, so it's 9. No, stay with me. Stay with me. So far? So you definitely do not have to get the end answer after one step. You could do whatever the hell you see works. Because the minute you get something to work, you're left with smaller numbers. And then your brain can go, okay, I can see those freaking numbers. Now I can see what to do. So you do whatever works. If they're both even, you divide by 2 at the least. Because you know 2 can go in if it's even. You with me? If they both end in a 5 or a 0, you divide it by 5. You start off. Maybe that's not the answer, but that's the good first step. Now, real quick. Let's see if you guys are with me. Do you see how that's 1, 3? So let's do this. I haven't talked about this directly yet, but we need this skill. Do you know how to break 243 up into its prime factors? You guys know prime factor tree?
Yeah.
So we did 243 was 3 times 81, right? So 3 is prime. 81 is 9 times 9. And each 9 is... So what is 243? How many 3's does it have in it?
4.
Careful.
5.
1, 2, 3, 4, 5. So it's 3 to the 5th. Are you with me? What's 27? How many 3's does that have in it?
3.
3. 3 times 3 times 3. So this, 243 over 27. 243 is 3 to the 5th. 27 is 3 to the 3rd power, right? 3 times 3 times 3. So if I have 5 3's multiplying, divided by 3 3's multiplying, how many 3's will be left? 2 will be left. 3 are going to cancel. You'll be left with 2 because you got 5 up top. You got 2 more up top that stay alive. So that would be 3 squared, which is 9. Same stupid answer we got there, of course. Because I just made the numbers look different. But now you know. See, look at all the freaking work it took me just to get it to look like this. So you got to realize, if they give you letters, that kicks so much ass. Because letters have to be factored already. What do I mean? I can have this problem. B to the 5th divided by B cubed. What am I on? That's F. Where did you get F from? We'll start over. B to the 5th divided by B cubed. B to the 2nd. You guys start to see the pattern? Because can you imagine in your brain, you got 5 B's on the top, right? How many on the bottom? 3. Now draw a line through how many of them? 3 of them. So how many's left on the top? 2. So you do this, but then you start to realize, I don't have to do this stupid thing every time, because how many will I draw a line through is how many are there. So there's going to be however many more there are up here left, so it'll be b squared. B times b is b squared. That's exactly the same thing this came out to be, isn't it? 3 times 3 is 3 squared. I had 5 3s over 3 3s, 2 3s left.
Not 15.
Say again?
Not 15b.
Definitely not, because again, I'm not multiplying. I am dividing, and they're not coefficients, they're powers. So if I ask you, is there a 5 or a 3 in this problem?
Yeah.
The correct answer is no. And this is where students kind of like, if you didn't know me, hopefully you know me well enough to stay with me. Right? If I said that the first day, if you walked out, I couldn't blame you. Because you're like, there's a freaking 5 right there. I'm out of here. If you can't see that 5, we're going to have problems. But there's not a 5 there. There isn't. What does that mean?
2.
I have 5 B's up there. Now look, is there a 5 in here?
No.
No, but you just told me that's the same damn thing. Is there a 3 in here? No. So those powers just tell me how many of these things I have. So it can't be 15. There's not a 5 or a 3 in there.
It's like minus, like 5 minus 3 equals 2.
Good. Beautiful. That's the pattern you start to see.
It's like you take away, right? So you're taking away 5b.
Yeah. So most of the problems in this section, you could actually kind of skip that that observation, that pattern. But real quick, let me do one more problem like that, and then I'll show you how you can tackle the ones in this section if you don't like this shortcut that I'm showing you. So if I had w to the 10th over w cubed,
W7.
w7, right? If you have 10 w's over 3 w's, die, there's going to be 7 left, because there's 7 more up there, right?
7w.
So it would be w to the 10 minus 3. Now, in the actual work, they don't give you a power that big. So you could do, if I had w4 over w squared, you could write that as w over ww. Is that cool? Because w4 means 4 w's. w2 means 2
This is
w's.
w.
How many cancel? Yeah, w squared. Right? And whereas the shortcut would say 4 minus 2 is 3 there. Right? So in the homework, you don't have to do the 10 minus 3 is 7 kind of thing. You actually could if you wanted to expand them, because they don't have these huge powers. But you can imagine if it was w to the 80th power, please, dear God, don't write 80 w's out. Right? But by the time we get there, hopefully we'll have talked more about that rule, and then it'll become part of what you need to know. So here's a problem exactly out of the homework that deals with letters. Alright, so let me show you how I can do this. If you don't like this rule, if you like the rule, it works beautifully. If you don't like the rule, you can always just expand what this means. What's x cubed mean?
3 X's.
Good. X times x times x. Y cubed?
3 Y's.
Y times y. Ah, got it. Y squared?
2 Y's.
Y. And x is incredibly x. So now what can cancel? What's on the top and the bottom that can cancel? How many y's could I cancel?
2.
2, because there's 2 there. So 2 of them cancel there. So how many y's are left? That 2's left alive, right?
1 of 1.
How many x's can I cancel?
1.
1, because this guy's only got 1. So if I cancel 1 x, there's no more x's left to kill. Right? So how many x's?
2x.
So it'll be x to the
Power 2.
second over 1. Now if you like the shortcut, this is x third, this is x to the first. 3 minus 1 is 2. 3 minus 2 is 1, but where were there more y's?
Down.
So I'm going to end up with 1 y left on the bottom. So the shortcut works quicker, but it requires you to really understand all the stuff going on. Where in that form, you just have to kill whatever's common. And that's really the only place that you have to be able to be here in this section. You don't have to know the shortcut that I showed you. How are we doing so far? So let me show you a problem with numbers and letters in it.
Yeah.
So they have some of those. So if I had something like that there.
Oh,
So if you wanted to, now the numbers are easy enough. They should be. The numbers you shouldn't have to do too much with. What numbers can I work with here?
9, is it 380? Oh,
It's a 3A. Sorry.
380.
The other one's 9 or
And it's a 9. Should have picked number 9. That's a big old 9 there, right? So what numbers can I work with?
3 with
9 with a 3.
Good. So 3
1.
goes in once, 3 goes in.
3.
Cool. Right. Now this b squared is actually b times b, right?
Yeah.
So how many b's can I kill?
1.
1. Careful, I can't kill 2 of them because how many are on the bottom is 2, but how many are on the top?
1.
1. So I can't kill more than 1. Once I kill 1, there's no other b to kill the other one. Right? So I rewrote this b squared there. So how many b's are left on the bottom?
1.
That one right there. So on the bottom I have a 3, and a 4, and a b. Can I kill that a?
No.
No.
Thank God, right? Why can't I not kill that a?
Both of them on the
They're both on the top. They're both multiplying. One is not dividing and the other one multiplying. That would be opposite operation. These are both on the top. They're both multiplying. They can't cancel. You guys with me? People get a little too optimistic and just start killing everything everywhere. But one has to be on the top and the other one's got to be on the bottom for them to cancel. So what do I have as an answer here? What's left on the top?
A, 2,
So a
over 2.
squared over
12B.
good. 3 times 4 is 12 times b is 12b. I like it. And that's going to be like the hardest mixture problem you'll see. Is mixing the letters and the numbers. But they actually work the same way. They work exactly the same way. Yes, sir.
How does it work? It's the same thing. It's different.
They're not.
DA.
I really, really want you to understand how they're not. Watch. Stay with me. If I had x cubed over x, what's x cubed mean?
3.
2x.
What about 3?
3x.
3 x's. So how many x's can I cancel?
4. 1.
1.
1x cancels. How many am I left with?
2x.
X squared.
I like it. So guys, stay with me now. What if I had this? Isn't 27 3 times 3 times 3?
9.
9.
Right? So how many 3's cancel?
1.
So see how they work exactly the same damn way, don't they? The beautiful thing about variables is they start off factored. Is 27 factored? No, I had to make it into 3 times 3 times 3. X cubed is already factored. It's already x times x times x. I don't have to waste any time thinking about how to break it up. It's already broken up for me. So variables are actually easier. It's just that we're not used to working with letters. Yeah.
So, can we do that? 3x, 3, can we just do it 9? 3, 9 equals 3?
Well, yeah, I know. Well, 27 divided by 3 is 9. But we're really looking to see why that's true. Right? We're seeing why it's true. And it's true because I can kill one of the 3's and I'm left with the other 2 3's. Because how many 3's is 27 made of?
No.
3.
3.
3 times 3 times 3. You with me? Okay. Yes?
But would the answer be 3 squared or would it be 9?
3 squared is 9. So that's the one place. X squared, I don't know what the hell it is. Because I don't know what x is. But 3 squared, I know it's 9. Because I know what the number is. Good. Yes?
So if we have like these occasions, like can we every letter goes with the similar one? Like
So
can we divide it? Like because like AB is different from 4B squared.
No, I like the question.
So we divide it and like we can.
So if I had this problem. That's fine. Okay. So, I really want you to understand how we're completely cool with 15 divided by 10. How could I reduce that? What's 15? 5 times 3. What's 10? 5 times 2. I can kill those 5s, right? No problem with that. But weren't they together?
Yeah.
Weren't 5 times 3, weren't they 15? So how can I just kill this part of it? That's really what you're asking. So I know this is 2xy squared, and this is y, but who cares? This is all what operation? What operation is happening here?
Multiply.
And what operation is this? Division. So the y's will kill each other. So you could, if you wanted to, you could write this all out. What's y squared?
2 by y by
Y times y. And x squared is xx. So really, what letter cancels? How many letters cancel here?
y and x.
Why?
Careful now.
Oh,
Only the y cancels. Why does only the y cancel? Why doesn't any x's cancel?
2 is 8.
Why don't any x's cancel?
on top.
Because all the x's are on the top. There's no x on the bottom to die, right? These x's cannot kill each other because they're on the same level. They're multiplying. There isn't one that's multiplying, one that's dividing. They're not doing the opposite operation. You guys all get that. I can only cancel stuff in a fraction or several fractions if something's on the top and the same thing's on the bottom. Because that would mean opposite operation. If they're across from each other, you got to multiply those things. You can't kill them. They got to multiply. So what happens with the numbers here?
8 with
The 2 goes into 8
4,
4 times.
1.
2 goes into 4
1.
2.
twice. Right? So what do I end up with on the top?
2,
And you have
4.
y.
1.
Huh?
You have y.
Oh yeah, the other y here. So
1.
another y dies, right? Cool, I like it. So I have an x, and I have 2 more x's,
4.
and a 2 on the bottom. I like it. So on the top I have x times x times x is
X
Right.
cubed.
x cubed. Good, I got 3 x's multiplying. And on the bottom I get 2. That's the only thing left alive on the bottom. All right. I think there's plenty of time on that, because there's not too many that are that weird. That's the hardest that they get in this section. I really want us to focus on just the basic reducing of stuff. Okay, but that is the kind of problem I desperately hope you see. And this is exactly how you can do it. You can expand anything with an exponent and just start killing each thing that's the same on the top and bottom. That's exactly how you can do this. Now, if you understand things a little bit better or a little more comfortable, there are some shortcuts you can take. But if you're not there, what the hell? Just do the idea. This is the idea of what's going on.
I got a quick question for you.
Yeah.
Mr. Long. It's actually on page 230. Write the prime factorization of each number.
Good. I like it.
The number's 48. I know what prime numbers are. I was just wondering if I just if I had a brain fart and just froze up on it, what it was.
All right, take a second and try to break 48 down into its parts.
I did.
8 and 6.
So when I say second, I mean a math class second, which is more like a minute. It's like a football second. Yes,
8 and 6 is 48.
that's true. So that's a good first step. Keep going.
And then
Because you got to break each piece all the way down. Don't say it out loud. I want everybody to try it. I don't see a lot of writing. Try to break 48 down. Some of you guys are still staring at me. Try to break 48 down into its parts. 48.
Oh.
No. Some of you guys are still staring at me, so I'll just accept that. Good first step. Keep going, and maybe don't say it out loud. Hold on to it. Hold on to it. So this is kind of cool when you break a number down. We're actually getting the number's DNA. Believe it or not. Right? And you guys are like, oh great, just bring chemistry into freaking math. Why don't you do that? So, I heard a couple different ways to start this off, so I'm going to do it both ways. I heard 8 times 6. I heard 4 times 12. Anybody else do it a different way?
2 times
24. Okay, cool. No matter which way you start, it's always got to come to the same damn thing at the end. Because you can imagine, if I get a string of numbers that multiply, they have to multiply to a specific number. Right? There's only one way. That's why I call it the DNA of the number. So 48, 8 times 6, keep going with each piece until they get prime. 4 times 2,
2 by
2 times 3. So prime, prime, prime.
2 by 2.
2, 2.
2 times 2.
2 to the 4 times.
I love it. So how many 2's are there? 4. So it'll be 2 to the 4 times 3.
Yeah, I got that one. But like when it's like big numbers, like 110,
All right, we'll do that now.
or like 80.
Now, if I do this one real quick,
Yeah.
2 by 2. 3 by 2.
6. Oh, 3 times 4.
it doesn't matter which way. I heard 2 by 6, but it doesn't matter. So 2, 2, 3, and 4 is.
2, 2.
So I still end up with 1, 2, 3, 4 2's and 1, 3. And of course, you get the same thing if you do the last one too.
You can just do however you want.
So that's why every number has a unique prime factorization. That's really, if you think about it, it's got to be that way. But at the same time, it's kind of cool. That is the identifier for 48. No other number can look like this, because that times that is 48.
Okay, gotcha.
How we doing?
Good.
So if we try a larger number,
Like, okay, a larger number, huh?
yes,
Like,
Okay, how about 828?
I like it.
yeah,
Kicks ass.
28. What the hell?
And the beautiful thing is the first step you take cannot be wrong unless you divide incorrectly. It's just whatever you see works. So what number works to start off with? What actually goes into 828?
414.
I like it. But that's divided by
2.
2. So you can break this up. It's even. So 2 definitely goes in.
Yeah.
Times, I'll just divide each piece by 2 and you get 4, 1, 4. Cool. So 2 is prime. Why do I keep saying that word? What's that word mean, prime?
Because it's
Only divisible by itself.
It's only divisible by itself in 1.
And 1.
So like 17, if I said break 17 up, you go, I'm done. 17 is 1 times 17. It can't be any other whole number multiplied by 17. Those are prime numbers.
yeah.
And to tell you honestly, there are math people that are searching for a pattern in the prime numbers. If you found that pattern, you would win so many cash prizes and be like the most famous math dude in history.
Really?
Or dudette.
Oh, because you
Why
figure out like
say that? We could add that number.
you can figure out lotteries and stuff.
Oh, how do I gotta go?
Oh, that's it.
Please.
He's like cash prices.
I like that. No, I mean, there are a lot of contests right now for finding a string, a pattern in the prime numbers. And just to let you know, it's probably not easy because they've been working on it forever. All the top mathematicians in the world. But you never know. Maybe they're overthinking it. Yeah,
But
exactly. Sometimes they are.
But how you get the 2s, like 2 4s? I don't
So are you
understand that.
cool with this?
Yeah,
So how many? What's this? This is 2 times 2
times 2.
times 2 times 2. Isn't there a more concise way to write that?
Do you like put the 2 and then put the 4?
No. You keep them broken up.
But I
You
don't-
keep them broken up like this,
yeah,
right?
and put 4.
No, you keep them broken up. Oh, I see what you mean. So 2 times 2 times 2 is 2 to the.
Yeah, 4.
There you go.
And then that one, I don't.
It's the same thing, isn't it? 2 times 2 times 2 times 2. It's 2 to the 4th.
And that one the same thing, right?
And that would become the same. It has to be the same thing.
Because
48 is 16 times 3.
so 16 times.
So 16 times 3 can only be 48. No other number can be broken down like that because that is 48. So keep it with this. You can't go wrong almost. As long as that number is even, you know that what goes into it. 2. Now take 2 into the parts.
7. Oh, just keep doing that.
2,
7.
07. Don't make it 27. No, it's 207, right? Now 207 gets freaky, but does anybody remember the shortcut I told you about if it is divisible by 9? 2 plus 0 plus 7 is 9, so 9 goes in, I'm guaranteed. Yes, sir.
But how do you get this 207?
I did 2 into 414.
7, it'd be 7. But
I just did 2 divided into 414, right? I'm trying to take 414 and break it up. So if I divide 414 by 2,
you don't times?
no, I'm taking 414 and breaking it apart.
So it's 14
Like 16 is 2 times 8. I'm trying to break it up into its parts.
You don't.
So 414 is 2 times what? Well, I got to divide it by 2 to see what it would be, right? So if I want to break 414 up into 2 times something.
that'd be 7. 2 7. That'd be 7.
2 times 7 is only 14. I need 414. Right?
That'd be something.
That's true. So to figure out what this something is, I would take 2 into 414. If I divide it by 2,
27.
2, no, careful. 2. Does 2 go into 1?
1. 2.
2 doesn't go into 1.
0.
2 goes into 14.
That'd be 1. 7.
Yeah. And we know that 400 something divided by 2 should be 200 something. So if you put 27 there, your brain should tell you, no, you forgot something. There's no way it's 27. Now, what did we just say about 207? Divisible by 9, because the numbers add up to 9, right? So 9 into 207?
23.
Yeah, 2. 9 into 27? 3. Right? And then we go for each imperial. Nobody got that reference? Yeah, I'm pardon. Circle the wrong
I
number.
gotta see it.
The number 23, everybody ever seen?
And
9 is
3 by 3.
3 times 3. You guys see what I'm doing? You almost cannot go wrong. If the number's even, you divide by 2. If the number ends in 5, you divide by 5. If the number ends in 0, you divide by 10. I love it. Right? Yes, sir.
What about like 93 though? I mean number 12, which is 93.
What definitely goes into 93?
1.
3.
I appreciate that answer because it's right.
3 goes in 93.
But what number besides 1 goes in 93? 3. And there you go.
So 3 times 31.
And 31 looks to be prime, and it is. I can't break 31 up.
Oh, okay. You can't break 31.
So the weird thing is when you get a large prime, and you're like, do I keep going? But 31, a damn thing goes into 31. Except for 31. Or 1. Yeah.
So I did that 23 times 9 is 207. 20,
Good. Just to check it.
29.
Just to check it. Sure. But we're taking 207 and breaking it up. So what
make
you
it
did was check it.
23.
So what is 820?